Hello students, I am Dileshwar Sahu. Today I am discussing about the Coulomb's law in electricity. Now, what is the Coulomb's law? The law states that the magnitude of the electrostatic force of attraction or repulsion between 2 point charges. It means there are 2 point charges, positive charge. When we take two positive charge, we know that there is a repulsion force, and we can take one positive charge and one negative charge there between attraction force. So we can say that this force is directly proportional to the product of magnitude of charges. Product of magnitude of charges means plus q and plus q, or plus q or minus q. These are the magnitude of charges. And after that, the second law says that the force is inversely proportional to the square of the distance between them. Between them means two charges. Okay. In vector form, we can say that F1 is a force expressed by Q1 and F2 is a force expressed by Q2. In diagrams, we can say that F1 is a force expressed by Q1 and F2 is force expressed by Q2. Two conditions we have: Q1 is multiplied by Q2 is greater than 0. It means the force acting between them is a repulsive. And Q1 multiplied by Q2 is less than 0. It means the force are attractive. We can discuss it briefly in the next page. Okay. In a vector form, we have a formula for F1. Q1 into Q2 is divided by 4 pi epsilon 0 is multiplied by R1 minus of R2 divided by of R1 minus R2 mod Q is equal to Q1 into Q2 divided by of 4 pi epsilon 0 is multiplied by R cap 12 upon mod of R12 square. Okay. The meaning of R12 is equal to R1 minus of R2, and the R cap 12 is equal to R12 upon R12 mod. Okay. That these two contents are related to this formula. Okay. And epsilon 0 is the electric constant and Q1 Q2 are the point charges. Okay. We have two conditions. When the Q1 and Q2 are the like charges, the magnitude of Q1 and Q2 is positive and the forces are repulsed between them. Okay. When we can take Q1 and Q2 are unlike charges, the magnitude is negative and the forces between them is attractive force. Okay. So we can say that this is the forces, this is the condition for F1, and we can take the condition for F2, but F2 is equal to minus of F1 because the forces, the direction of forces is different. Okay. Opposite. So F2 is equal to F1. This is the Newton's third law. We know that the direction what is the Newton's third law? We have a formula of constant Ke is equal to 1 upon 4 pi epsilon 0. The epsilon 0 is a vacuum electric permittivity, and it is also called electric constant. Its unit is Coulomb square per meter square into Newton. Okay. This unit is also derived from the Coulomb's law. Okay. And epsilon r is called the relative permittivity. It is different from the epsilon 0. Okay. Epsilon 0 is a vacuum and epsilon r is a relative permittivity. But when we multiply the epsilon 0 and epsilon r, it is equal to the epsilon a. Epsilon is the absolute permittivity of material. Okay. The value of Ke is equal to 8.98 into 10 to the power 9. It is a lots of values, but we can take 8.9 is also approximate. We can take 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay. Newton meter square per Coulomb square. Okay.